Okay, today we will discuss about organotins. Okay, it's also called as organostananes. So that means carbon SN bond containing compounds are called organotins or organostananes. So tin has more metallic character. Tin has more metallic character than silicon. So in +4 state forms stable organic compounds. So tin forms stable compounds in +4 state. Size of the atom is larger than carbon and silicon. Hence, it forms long covalent bonds that are easily polarized. Organotin chemistry exploits the weakness of the stannous carbon bond uh, to deliver whatever is attached to the tin to another reagent or compound. Carbon substituents present on the tin can be transferred by a radical mechanism. I think you are aware about pre-radical mechanism. So that means here we are talking about pre-radical mechanism with respect to transforming of groups attached to the tin to a substrate due to the weak covalent bond as well as bipolar mechanism. Organotins are stable liquids stored easily, unlike Grignard reagents. So Grignard reagents are moisture sensitive. Storage is difficult. Okay, why? Because if it absorbs a moisture in the sense whatever the if we are allow it to pass a air itself contains moisture, then Grignard reagent destroys itself. That is the problem with the Grignard reagent. That means Grignard reagent requires a argon atmosphere. Argon means so there is no moisture in it. Organotins are more reactive than organosilicon compounds. So with this, I will go to the next slide. Next slide will give you the information about the bond length. Okay, the bond length of uh, okay, the bond length of a different silicon carbon, stannous carbon, silicon oxygen, silicon carbide, silicon hydride. So that information is available in the next slide. So with this, I will go to the next slide. So look here. because bonds are weaker and it's more electropositive than silicon. Important organotin is tributyl tin hydride. Tributyl tin hydride, in short form, it is used to call it as a TB uh, TH. TBTH means tributyl tin hydride. So Bu3SNH is also called as tributyl tin hydride. So this is most important organotin compound, and this is used as a reducing agent. So here I'm mentioning the bond length, nature of bond and bond length. Carbon-carbon bond length is 0.153, silicon-silicon 0.21, stannous 0.28. Of course, your stannous in the sense what you call a tin element, uh, it will have a two variable state. One is +2, another one is +4. So stannous refers for +2 state, stannic refers +4 state. So stan and then stan bond is around 0.28. Silicon and carbide bond length is 0.18. Stannous and carbon is 0.22. Carbon and hydrogen 0.10. Silicon and hydrogen 0.14. Stannic and hydrogen is what you call 0.17. So this is about bond length. And with this, I will go to the next slide. Next slide will give you the information about preparation. So preparation of uh, stannic compounds. So look here. So this is called tributyl tin chloride. Tributyl tin chloride, when it is treated with lithium aluminum hydride, so it gives a tributyl tin hydride. This is only TbTH. This one is used as a reducing agent. Of course, if you want to know how the tributyl tin chloride is obtained, so this tributyl tin chloride is obtained starting with the stannic chloride. SnCl4 means it's a stannic chloride. SnCl4 is a solid, okay, and uh, what you call tetra alkyl or butyl tin, okay, is used, and this will react with the stannic chloride forming a tributyl tin chloride. Similarly, this is if you want to know how the tetrabutyl tin is obtained. So tetrabutyl or tetraalkyl tin can be obtained starting with the stannic chloride and RMGX. RMGX means magnesium alkyl magnesium halide. So that is how a tetraalkyl stannic compound is obtained. Suppose if you are treating a trimethyl tin chloride in presence of stannic chloride, what will happen? So you know that uh, there will be a bond formation. How the bond formation? 2-methyl group is replaced with two of the chlorine. So that is how dimethyl dichloro stannic uh, 4 is obtained. So dimethyl dichloro stannic 4 is obtained. So the obtained one, if it is treated with one more equivalent of RMGX, what it will do? It replaces one of the chlorine. So that is how dimethyl alkyl stannic chloride is obtained. Again, if this is treated with a different alkyl magnesium halide, so then it will give you a substituted dimethyl stanic 4 is obtained. And one more thing is possible. You can observe that trialkyl styrene chloride, if it is treated with Y, so Y is a nucleophile. So Y nucleophile may be a methoxy, may be a amine, may be a thio compound, may be a ester, etc. So that means it is possible to replace the chlorine attached to the stannous element. So that is the reason this type of reactions also is possible, and this is also a organostanic compound. So with this, I will go to the next slide. Next slide will give you the reactions of organotin compounds. So look here, this is the one. I think you are aware about the reduction of halides. Okay, so conversion of organo halide, otherwise haloalkane or haloarene to the hydrocarbon. So here what is important, Rx is converted into RH. RH is hydrocarbon, Rx is haloalkene or haloarene. So for this conversion, a reagent, it's called TB, tributyl tin hydride, TB TH. TBTH is nothing but a tributyl tin hydride. It's a reducing agent. It will act as a source of H minus. H minus means hydride. But actually here H minus and all we are not talking, because it follows free radical reaction. So what is AIBN? AIBN is called aza isobutyronitrile. Aza isobutyronitrile. Aza isobutyronitrile is a radical initiator. So just like what is called as peroxide is there, no? In that way, aza isobutyronitrile is also a radical initiator. So what will happen here? So this is the reaction. In the reaction, a alkyl halide or aryl halide is converted into hydrocarbon. So if we are looking into the mechanism, AIBN, so it will break. How it will break? I think you are aware about the homolytic cleavage. So homolytic cleavage means the nitrogen takes its electron, this carbon takes its electron, homolytic cleavage. This carbon takes its electron, nitrogen takes its electron. So one electron from here, one electron from here, a byproduct N2 is going out and forming a isobutyronitrile radical. This isobutyronitrile radical, this is how the free radical is initiated. So next step is the propagation. So the obtained free radical, it is react with tributyl tin hydride. How it will react? There will be a homolytic cleavage between the stannic and hydrogen. Okay, stannic and hydrogen. Right. So now what will happen? Free radical is formed, and there will be a cleavage here between the stannic and the hydrogen. So then this what is called as hydrogen radical, it will form a bond with isobutyronitrile. And here there is a generation of new free radical, that is tributyl tin radical. This tributyl tin radical react with the alkyl halide. So now all the alkyl halide will undergo a homolytic cleavage. So then what it will form? X means halide will form a bond with the tin. So that means tributyl tin hydride is a tin halide is a neutral compound, whereas the formation of new free radical called alkyl radical. This alkyl radical reacts with one more equivalent of tin hydride, means tributyl tin hydride. So then R is converted into RH. So this is how the alkyl halide is converted into uh, hydrocarbon, and this will be the mechanism for the conversion of alkyl halide to hydrocarbon, and in this isobutyronitride is acts as a radical initiator. Okay, this is about the mechanism. So right, so this is that means R can be anything, okay, alkyl or aryl. Okay, then you will get a respective hydrocarbon. This is about what is called as uh, conversion of acid halide, means alkyl halide or aryl halide to the hydrocarbon, and this process is called reduction, and the reagent used here is tributyl tin hydride. So with this, I will go to the next slide. So next slide, it's about features. So features of this reduction. So relative rate of obstruction of halogen by tributyl tin radical is, that means iodine obstruction is more compared to the Br, compared to the chlorine, compared to the fluorine. That means R chloride or R bromide or R iodide, when it is treated with UV. UV, you think light source. So light is the initiator, radical initiator. Light is the radical initiator in this reaction. And tributyl tin hydride is it will act as a source of hydrogen radical. So that is how a halide is replaced with hydrogen. And the reactivity order of a different halide means benzyl halide is more reactive compared to the allyl halide. Allyl halide is more reactive compared to the trialkyl halide. Trialkyl halide is more reactive compared to the secondary alkyl halide. And secondary alkyl halide is more reactive compared to the primary alkyl halide. So primary alkyl halide is more reactive compared to the vinyl halide. Vinyl halide is more reactive compared to the aryl halide. So that means aryl halide is the least reactive, and benzyl halide is the most reactive. Okay. So for example, I think you are aware about the halide and gem halide. So that means if the two halogens are attached to the same carbon atom, that is called gem halide. And one more halide is a simple halide. So if there is a substituent contain a gem halide, and if another substituent contains a gem halide, so gem halide undergoes uh, uh, reduction, okay, with tin tributyl tin hydride, okay. So this is one example of gem halide, because this carbon contains two halides. Okay, it's a gem halide. So what will happen here? What you can observe? Chlorine and fluorine. So chlorine is the higher molecular weight. So this chlorine is replaced with hydrogen. Okay, the product is this. So you can take this example, you can write the mechanism. What is the mechanism? So first AIBN undergoes homolytic cleavage, forming a free radical. That free radical react with the tributyl tin hydride, forming a butyl tin radical. Butyl tin radical react with this reactant and forming a R radical. That R radical again react with one more molecule of tributyl tin, giving rise to this product. So four steps are involved in the conversion of halide to hydride. So this is one example. In the next slide, I am taking few more, three examples. So look here. What is there here? Chlorine and methyl. So chlorine is the higher molecular weight. That is the reason this chlorine is replaced by hydrogen. So that is this one. And here two halides are there, chlorine and bromine. So chlorine is the less molecular weight compared to the bromine. So this bromine is replaced with hydride. So that is the product. And here it's a bicyclic compound. Here both the gem halides. Okay, in that one of the chlorine is replaced with hydrogen. This is the one. So in the next slide, I am taking three more examples. So look here, this is a gem. And one more thing, it's a bicyclic compound, more particularly a 7-membered and a 3-membered ring bicyclic compound. So here you can observe that two are bromine itself. Okay, this is one bromine, this is another bromine. What is happening? This is a radical initiator, and here both the hydrogens, this hydrogen as well as this hydrogen, both the hydrogens are replaced with the hydrogen. So that is how the product is obtained. And here I am taking one more. This is the chlorine, and this will be the substituent, and this chlorine is replaced with the hydrogen. That's what the product. And here, so I think you know that this moiety is called 8-membered ring moiety. This is cyclopropane, this is also cyclopropane, this is the 8-membered ring. So what is happening here? So one of the hydrogen is replaced with hydrogen. Okay, you can write the mechanism. Okay, I will tell you one more example also. There a rearrangement is involved. Okay, so that mechanism also you can write. So with this, I will go to the next slide. So look here. This is one. So I think you know that this is the intermediate. How this intermediate is obtained? So when AIBN is a radical initiator, when this radical is initiated, that was treated with an alkyl halide. So there will be a clear homolytic cleavage here, forming a radical here, forming a radical here. Okay, if there is a radical formation here, that's what I have written here. So you know that since there is a radical on the primary carbon atom, so there is a triple bond here. Means one of the bond pair can break. It means that there will be a new bond formation between this carbon and this carbon, and there will be a formation of radical on this carbon. So that's what I have written here. So this radical, when it is treated with butyl hydride, so there will be a new bond formation between this radical and the hydrogen radical. That is how the alene compounds. Name of this compound is called alene. Alene means double bond, double bond. Okay, double adjacent double bond. Okay, is called alene compounds. What it means? Some of the intermediates rearranges. Okay, and giving rise to a different product. Suppose this moiety, when it is treated with tributyl tin hydride, there will be a new bond formation between this radical and hydrogen radical. So that is how the product obtained. So with this, I will go to the next slide. So look here. Here I am taking a different one. So what you can observe, numbering you have to start with this 1, 2, 3, 4, 5, 6. So sixth bromo means you can say that 6 halo alkene. This 6 halo alkene, when it's subjected to AABN, is a radical initiator, and there will be a radical formation here. Suppose if there is a radical formation here, so this and this, there is a double bond. This double bond can undergo homolytic cleavage, forming a radical here and radical there. Then what will happen? This radical and this radical form a bond and forming a 5-membered ring. And later on, if it is treated with the tributyl tin hydride, so CH2 will be converted into CH3. So for this mechanism, you can write the mechanism. For this reaction, you can write the mechanism. For this also, you can write the mechanism. So what is here? A triple bond is there. 6 halo alkyne. When it is treated with AIBN, it's a radical initiator once the radical initiator is obtained, it will react with this carbon, and there will be a breakage forming a radical here, radical there. This radical, and here triple bond, homolytic cleavage forming one radical here, one radical there. So then there will be a new bond formation between this radical and this radical. So later on, that product, when it is treated with the tributyl tin hydride, CH2 is coming like this. So here I am writing one more thing. You can observe that this is a double bond and this is an alkyl halide. A beam is a radical initiator. So it will initiate radical at this position and this will break out, and there will be, and this double bond homolytic cleavage forming a new bond between this radical and this radical, and there is a radical here. Okay. So with this, we'll go to the next slide. So next slide is this. So what is the products here? It's a halene, and this is a double halide, halene halide. What will happen here? So this is a radical initiator. There will be a breakage here forming a radical here. Afterwards, what will happen? And this double bond, homolytic cleavage, forming a new bond between this carbon and this carbon. Okay. So there will be a radical forming here. This radical is catalyzed. This radical picks up a hydride radical from butyl tin. So that is how this product is obtained. Similarly, this is another compound. So when radical is initiated by AABN, so there will be a radical formation here. This radical react with the this particular bond. How it is reacting? This hydrogen homolytic cleavage forming a radical here and radical both the radical forming a bond. So that is how this product is obtained. Okay. So this is about what is called as few reactions. Okay, few reactions of the application of organotin compounds in organic synthesis. Okay. So with this, I will take up one more reaction. I think you are aware about dehalogenation. So up to this, we discussed about dehalogenation. That is a one kind of examples. Another example also we discussed, dehalogenation followed by intramolecular cyclization. Now we are looking at the dehalogenation by intermolecular carbon-carbon coupling, means bond formation. So what are the points between alkyl bromide or iodide and alkenes? Alkyl halides may be primary, secondary, or tertiary. Alkenes may be what is terminal or internal. Okay, alkenes may be terminal, means at the one end of the structure, or may be internal, in between, having a free radical substitution substituents, free radical substituents. What will happen here? Stabilizing the substituents on vinylic carbon. So this is one Ri, CH2 double bond CHZ. Ri, CH2 double bond CHZ. Okay. Then here R, CH2, CH2Z. Okay. So the where Z is equal to Cn. So that means this is Z is equal to Cn, means electron with the drawing group. CO means what is called as a keto, nitrile, a keto, an aldehyde, an ester, and phenyl group. So that means here Z may be a electron withdrawing groups. So what is happening here? There will be a reaction between alkyl halide and then alkene. Suppose alkene should contain an electron withdrawing group. So what will happen? There will be a reaction. Iodide is going out, but this R is forming a bond with this carbon. That's what the product is obtained. If you want to look into how this product is obtained, so you know that here the TBTH. TBTH means it is a tributyl tin hydride. Tributyl tin hydride in presence of light or in presence of AIBN, it forms a radical. This radical reacts with alkyl halide. If this is reacting with alkyl halide, that leads to the formation of alkyl radical. This alkyl radical react with the reactant. So this is a react. How it is reacting? The double bond or pi bond undergoes a homolytic cleavage, forming a radical here and one more radical. That radical forms a bond with R. So that is how this product is obtained. Now there is a radical here. So at this stage, what will happen? So this can be rearranged. How it is rearranged? This CH bond can, what is that? This hydride can form a, means hydride radical can form a bond with this. And here there is a possibility of forming a radical. This radical again react with tributyl tin hydride. Tributyl tin hydride. This act as a hydrogen radical, and that is how a product is obtained. Okay, so this is about what is called as a coupling reaction. More particularly, alkyl halide is coupled with the alkene, provided the alkene should contain a electron withdrawing groups. And here the reagents are tributyl tin hydride. Reaction conditions may be tributyl tin hydride in presence of light or tributyl tin hydride in presence of what is called as radical initiator. So with this, I will go to the next slide. So this is a few examples I am discussing. You can observe that this is a cyclohexyl iodide. Cyclohexyl iodide, when it is reacting with uh, what is the name of this compound? This group is vinyl. Okay, vinyl methyl ketone. Vinyl methyl ketone. What will happen here? TBTH and AIBN. So TBTH means what we can say that it's a tributyl tin hydride. So what will happen? There will be a new bond formation between this carbon and this carbon. Okay, then right. So the product is obtained like this. So new bond formation between this carbon and this carbon, and this can fix up a radical, H radical. So this CH is converted into CH2. So that is the product. You can write the mechanism. But here I am taking a aryl halide. This is aryl group. So this aryl halide, when it is treated with acrylonitrile, name of this compound is called acrylonitrile. And then what is the name of this compound? Name of this compound is called acrylamide. Is it acrylamide? It's not an acrylamide. It's an acrylo methyl ketone. Of course, you can also say that vinyl methyl ketone, but this is acrylonitrile. So what is here again? AABN is a radical initiator. So there will be a formation of radical, and that radical leads to the formation of radical here. This radical forming a bond with this carbon, and there will be a formation of radical here. This radical is picks up a hydrogen radical from the TbTH. TbTH means tributyl tin hydride. So this is about what is called as uh, reactions, otherwise application of tributyl tin hydride, otherwise application of tin compounds in organic synthesis. So few more application also is there. So few more applications of organotin compounds that I will discuss in the next class. Okay. So up to this, if you have any doubt, you can ask me. If you don't have any doubts, you can log out.